Good day and welcome once again to Lesson 5. In Lesson 5, we're going to be looking at root cause analysis. Root cause analysis. My name remains Engineer Sonny Ogboji, and I'll be leading us through some discussions on root cause analysis. To start with, what is root cause analysis? Root cause analysis, RCA, as the acronym, is the process of discovering the root causes of problems in order to identify appropriate solutions. Most engineering problems present themselves via one symptom or the other. And if you are not careful, you might be treating symptoms without really addressing the underlying causes of these symptoms. For instance, for example, you have a situation where a bearing is collapsing. A roller bearing is collapsing. Every week as you come for maintenance, you open your bearing housing, you discover that the bearing has collapsed, the cage has collapsed, all the rollers have scattered, they are in the housing and they are mixed with your grease and everything. You replace. Next week, you discover that you have the same issue again. Now, if you are the type that want to treat symptoms, you might just be changing bearings. But this comes at a huge cost and nobody is going to listen to you after a while. Appropriately, you need to investigate what is the cause of this frequent collapse of bearing. Why are the cages given? What are the underlying factors? What could be the cause? What could be the reason why the bearings don't last as they are supposed to last? And that attempt at investigating or isolating the cause is what we call root cause analysis. It assumes that it is much more effective to systematically prevent and solve the underlying issues rather than just treating the ad hoc symptoms. Because the symptoms may change, they may get complicated, they may move from one pattern of manifestation to another. So if you are following the symptoms, you could be far away from the root cause and it could mess you up big time. The objectives of root cause analysis. There are three principal objectives of root cause analysis. The first is to discover the root cause of a problem or an event. The event itself is isolated in nature, but you want to trace it, link it to a cause. What exactly is causing it? Why am I having this issue or this manifestation? The second one is to fully understand how to fix and compensate or learn from any underlying issues within the root cause. Because if I'm able to isolate the cause, I would have learned some lessons. I would have known, okay, this is why this is happening, and this is what's leading to the symptom I am seeing. I could then be able to take appropriate measures, either to prevent a reoccurrence or to redesign, like we looked at in Lesson 1, under Design Out Maintenance. I could redesign, eliminate the root cause, and have a more stable operation. Then to apply what we learn from this analysis to systematically prevent future issues or to repeat our success stories. Root cause analysis thrives on some core principles. And what are the principles? About 6 or 7 of them. Root cause analysis, firstly, it focuses on correcting and remedying root cause rather than just the symptoms. It targets the root cause than just correcting symptoms. The second one is that the second core principle is you don't ignore the importance of treating symptoms for short-term relief. Now, it is important to treat or address the symptoms just for some short-term relief, but it is more important for us to be able to isolate the root cause so that we can be able to eliminate it entirely. So you don't ignore the symptoms, but you go beyond the symptoms to isolating and handling and correcting the root cause. Principle number 3 is that you must realize that there can be and often are multiple root causes. In troubleshooting an equipment, for instance, we said in troubleshooting, you are carrying out a systematic investigation to be able to a logical and systematic investigation to be able to determine or isolate the cause of a fault with the least likelihood of error within the shortest possible time with a view to fixing it. That's troubleshooting, and it takes place in every branch of engineering. In the course of troubleshooting, you might discover that you stumble at a root cause, and the temptation is to quickly conclude that this is why I am having the symptoms or the failure symptoms I have been encountering. But there may be one more than just that one root cause. And so we must realize that there can be two or more or multiple root causes for a particular symptom. And when you have a case of multiple root causes, you must be able to isolate the particular one that is resulting in whatever you are experiencing so that you can begin your maintenance and correction from there. Another one is we must focus on how and why something happened, not who was responsible. In root cause analysis, as much as possible, we don't look at the individuals. We look at the issues involved, how they are happening and why they are happening. We try to be very, very non-personal as far as root cause analysis is concerned. Another principle is you must be methodical and find concrete cause-effect evidence to back up your root cause claims. You must be so convinced, having methodically investigated and logically considered the facts on ground, that when you arrive at a particular conclusion, you'll be able to say with all certainty that this is the cause and these are the effects of this cause, and you tie them together and nobody will be able to fault your claims. Then the next principle is that root cause analysis must provide enough information to inform a corrective course of action. It does not stop at, this is what is causing it. Yes, you have identified what is causing it. How do we solve it? A good approach to root cause analysis will aim at what? Identifying and providing enough information on how to correct the errors that have been able to isolate. And lastly, root cause analysis consider how a root cause can be prevented or replicated in the future. You want to make sure that it does not happen again. You want to make sure that it does not come up again. And so you are correcting what you have seen, or you're also preventing a reoccurrence. It might involve change of components, it might involve change of technology, it might involve some modification, some isolation, whatever you do to make sure that it does not happen again. That is one of the core principles of root cause analysis. Having looked at the objectives and the core principles of root cause analysis, we want to look at the steps involved in root cause analysis. And there are basically 3 steps involved in root cause analysis. Step 1, define the problem. Step 2, collect data. And step 3, identify possible causal factors. I want to look at the steps in details. And they come mostly, what helps you in root cause analysis is ability to ask questions. You ask yourself, you ask any other operator, you ask other technicians that are there, because you want to get information. It's all about information. You want to get as much information as possible so that you can arrive at a workable conclusion that is acceptable and that is effective. So step 1, define the problem. That's the first step. What do you see happening? It may range from the fact that a shaft is vibrating to the fact that you see smoke coming out of that motor, or you see that that side of the electrical panel is heating up, or you see that there's a discoloration somewhere which suggests that there's some heating up that is taking place in that subsystem. What do you see? A good troubleshooter must be able to use his eyes very well, use your ears very well, use your senses very well, and you can only know that something has gone wrong if you know the right operational state or the right operational condition of that particular machine or part of machine. If you don't know what it means for it to be working right, you don't know when something is wrong or it is not working correctly. So what do you see happening? It helps you define the problem. Secondly, what are the specific symptoms? Oga, the machine is now fine, it no work well. That is not an answer. You want to be sure, okay, what do you mean by it is not working well? You want to be sure. What are the specific symptoms? Is there a vibration? Is there chain jumping? Is there a torn belt? Is there an entanglement? Is there a broken shaft? Is there a cam that is disengaged? A follower that is not working? You want to be sure exactly what is wrong. So in defining the problem you are answering 2 questions. What do you see happening and what are the specific symptoms? Then we move on to step 2, collection of data. Collection of data. What proof do you have that the problem exists? It is data, the data you are able to collect and generate, that will help you in proving, or that will serve as proof for you that there's a problem indeed. How long has the problem existed? At what point did they start noticing, the operator or yourself start noticing that there's a malfunction in somewhere? You want to be able to establish a timeline. Then what is the impact of the problem? What is the impact of the problem? And finally, under data collection, there will be need to analyze a situation before moving on to look at factors that contributed to the situation. You carry out thorough analysis. You disambiguate it. You break it into as little, every small size of component. You break it into very, very small components, and you look at each so that you can be able to analyze properly and then make your conclusions. So we are looking at 4 things under data collection. What proof do you have that the problem exists? How long has the problem existed? What is the impact of the problem? And then analysis of the situation. That takes us to the final step in root cause analysis, and that is step 3, identifying the possible causal factors. What sequence of events leads to the problem or led to the problem? This one failed, and then it resulted in this one happening, and the other one happened before it finally failed. We want to be sure. What is the sequence? For instance, a roller stopped. That is the first thing that you saw happening under step 1. Now, what led to the roller stopping? In the course of your root cause analysis, you will discover that the first thing that happened was that the drive that is powering, the gear drive that is powering the roller stopped. It was no longer moving. And for the drive to have stopped, you also discover, in the course of your troubleshooting, that the electric motor that is connected to the pinion was not driving. That's why the bigger gear did not drive and the roller could not move. What led to the electric motor stopping? It was noticed that there's some smoke and there's some smell of a burnt coil coming from it. And as a result of it, it just stopped working. So you are looking at the sequence of events that led to the problem, which is the fact that our roller has stopped rolling. What conditions allow the problem to occur? And then what other problems surround the occurrence of the central problem? By the time you are able to painstakingly answer these questions, you would have defined the problem, step 1, you would have collected data, and then you would have been able to correctly identify the possible causal factors for that particular problem. And finally, under root cause analysis, we want to look at the tools to use in identifying our causal factors. What are the tools that we use in identifying our causal factors? The first thing is to use the facts and ask, so what, to determine all the possible consequences of a fact. First, you are armed with a fact. The fact is, there's a burnt this thing I can see. There's a broken sprocket. There's a resistor that is burnt. There's a motor that is not working again. It cannot even turn. It is hooked. All these are facts. So starting from the facts, you want to ask your 5 whys. Ask why until you get to the root of the problem. Why did it stop? It stopped because there was no power entering again. Why is it that the power didn't enter it? There's a disconnection. Why is it that there's a disconnection? Is it sabotage, or is it that something mistakenly fell on it or whatever? Why and why? By the time you are able to ask about 5 whys, each answer generating another why, you would have discovered the root cause of the problem. Then you drill down. It's another tool. Either we use the 5 whys or we drill down. What does it mean to drill down? Break down a problem into small, detailed parts to better understand the big picture. You break into small, detailed parts to better understand the big picture. When you hold it as a complete, as one big whole, it will be difficult to understand. But when you take it one portion at a time, it will help you to better understand all the issues involved. and then you can get a better grasp of the bigger picture. Then the last tool we use in identifying causal factors in root cause analysis is what we call the cause and effect diagram, popularly known as the Ishikawa diagram or the fishbone diagram. Here you create a chart of all the possible causal factors to see where the trouble may have begun. It's just like a fishbone, or the veins on a leaf. You see the final problem or the problem you are trying to investigate at the end, and then you start isolating and identifying one by one what are the issues that could have resulted in this. The aim is to help you consider painstakingly each of the possible causal factors, and at the end you can narrow down your decision to a particular thing that could have resulted in the problem you are having. So far we have looked at root cause analysis. First, we began by answering the question, what is root cause analysis? And then we looked at the objectives of root cause analysis, which you say are three: discovering the root cause, understanding how to fix or compensate it, and then applying what we have learned to prevent further occurrence of those faults. Then we looked at about 6 core principles of root cause analysis, and we now looked at the steps involved in root cause analysis, which you say are 3: defining the problem, data collection, and identifying the possible causal factors by painstakingly considering the data you've been able to generate in step 2. And lastly, we looked at the tools. And we say the tools, number 1, you can use 5 whys. You first ask a why, and once you are given an answer, that answer should produce other whys. By the time you are able to ask 5 whys along the same line, you will get all the information you need as per the root cause and how it progressed to result in what you are looking at. Or you drill down, which we said is to break down a big problem into very small component parts so that you can, with ease, examine each of the component parts, and then putting them together, you have a better understanding of the big picture. And finally, we say you can use the cause and effect diagram to look at the effect retrospectively from the angle of the cause. Thank you very much. That will be the end of our lesson.